Okay, so section 3.3, slope of a line. So first off, suppose I have some line in the plane, and suppose that this is relative to some coordinate system, and suppose that this is not a vertical line, meaning that this line is not parallel to the y-line. Then, if I take a point on the line, and if I go 1 unit to the right, then the number of units that I have to go until I meet the line again, let that be m. We'll call that the slope of the line. And well, the slope of the line will be the same if you pick any point on the line. And we'll have the following understanding, that if we have to go up to get to the other point on the line, then we will have that the slope will be positive, whereas if I have to go down to get to a point on the line, then I'll make the slope be negative. Okay, so let me give you further terminology. So suppose I have a line in the plane relative to some coordinate system. And again, assume that this is not a vertical line. Then the slope of the line will be the rise over the run. So it will be the rise over the run. So the distance that you move in the x direction, well, the distance that you move in the y direction over the distance you move in the x direction. With the understanding that, well, your rise is positive if you're going in a positive y direction, and negative if you're going in a negative y direction, and the run is positive if you're going in a positive x direction, negative if you're going in a negative x direction. Or I can say it is, well, maybe I should put the rise a little higher. It is the vertical change over the horizontal change. These are just terminology, different terminology for the same quantities as rise over run. It is, let's use blue, change in y over the change in x. So change in y over the change in x. Maybe I'll use green. I'll use green. So the change in y we sometimes denote it by delta y. Change in x we denote it by delta x. So delta y over delta x. And that's the slope. Okay. Now, suppose that the coordinates of this point are x1, y1, and this is, say, x2, y2. Then this is just equal to y2 minus y1 over x2 minus x1. Of course, I'm assuming that x1 is not equal to x2 because I do not want to divide by 0. So these are differing ways of saying the same thing. And you should be familiar with all of them because I'll be saying them at different terminologies at different times. So note the following. The slope of a vertical line is undefined. So in these above definitions, I only gave you slopes for non-vertical lines. So I didn't define the slope of a vertical line. So, well, some people say that the slope of a vertical line is infinite in size. Okay? Or you can just say that it's undefined. We haven't defined it. But note that the slope of a horizontal line is defined and it's equal to 0. Oops. So the slope of a horizontal line is defined and it's equal to a very nice number. It's equal to the value 0. Okay. Note the following. You should never use the terminology no slope. Because basically students use it for both situations. They use it for if a slope, well, what's the slope of a vertical line? Well, it has no slope because it's undefined. Or they'll say the slope of a horizontal line has no slope because the slope is 0. So because of this confusion, just never use that terminology. Just never say no slope. Okay? So, give you some additional terminology. Parallel lines. So two lines in the plane, call it L1, L2, are said to be parallel, denoted by L1, two parallel lines, L2. These two lines in the plane are said to be parallel if they never intersect. And so if these two lines, here, let's make it a little bit better. That looks better. If these two lines never never cross path, they never intersect at any point, then we say that they're parallel. Suppose that I have these relative to some coordinate system, and suppose that these are non-vertical lines. So non-vertical lines. Then let M1 be the slope of L1, M2 be the slope of L2. Then two lines are parallel if and only if their slopes are the same. And so if the slopes are the same, then they're parallel. If the lines are parallel, then the slopes are the same. Of course, this is also true if they were vertical lines, because then you just say, well, if one side is undefined, then so is the other side. Perpendicular lines. Okay, so suppose I have two lines, L1 and L2. And suppose that neither of these lines are vertical. And so relative to some coordinate system. So suppose I have this coordinate system here. So suppose that relative to this coordinate system, they're not vertical. Then the slopes exist, and so call this line M1, this line M2. Then two lines, L1 and L2, would be perpendicular if they intersect at one point, and at that point of intersection, they intersect at a right angle. Well, two lines are perpendicular if and only if the product of their slopes is -1. And well, this is the same as saying that two lines are perpendicular if the slope of one of the lines is equal to the negative reciprocal of the slope of the other line. Of course, we can also say that this is also true for if one of the lines were vertical, just with the understanding that infinity times 0 is -1, and the reciprocal of 0 is infinity, and the reciprocal of infinity is 0. So if you make those assumptions, then this is true in all cases. Okay, so let's do some examples on page 121. Let's say that I want to do problem number 1. So in problem number 1, I'm given 2 points. And so in exercises 1 through 16, find the slope of the line passing through the given pair of points. So I'm given the points 3, 2, and -2, 4. So let's call this, and it doesn't really matter what I call this. Maybe I'll call this x1, y1. And I'll call this other one x2, y2. So the slope is just y2 minus y1 over x2 minus x1. And so y2, 4, y1, 2, x2, negative 2, x1, 3. So I get 4 minus 2, 2, over negative 5. And so my slope is a negative 2/5. Let me do problem number 3. One, negative 1, negative 1, 1. Okay, so the slope is equal to y2 minus y1 over x2 minus x1. Let me call this x2, y2, and call this x1, y1. So if you line them up nicely like this, then you just do negative 1 minus 1. So you just do a negative 1 minus 1 over 1 minus a negative 1. Okay? So if you line one on top of the other, then you just do the difference of this divided by the difference of those. Okay, so I get a negative 2 divided by 1 minus a negative 1, same as 1 plus 1, 2. Negative 2 divided by 2 is a negative 1. And that is your answer. Let me do problem number 5. Negative 2, 3. Negative 2, 5. So let's call this x1, y1, x2, y2. So m equals y2 minus y1 over x2 minus x1. So 5 minus 3 over negative 2 minus a negative 2 gives me 2 over negative 2 minus a negative 2, same as negative 2 plus 2, which is 0. 2 divided by 0, undefined. So this is the case of a vertical line. Let me do problem number 7. 4, 1, negative 5, 1. So let's call this x2, y2. Call this x1, y1. So I get the slope is equal to y2 minus y1 over x2 minus x1. So notice that it didn't matter if I called this first point, this the first point, or the second one the first point. It's not going to make any difference. Just as long as, if this is the first x coordinate, then this has got to be the first y coordinate. And so, y2 minus y1 over x2 minus x1. 1 minus 1 is 0. 4 minus the negative 5 is the same as 4 plus 5, 9. 0 divided by 9 is 0. So slope of this is 0. And so that this is the case of a horizontal line. Let me do problem number 9. Three, 0. 0, 4. So let's call this x1, y1, x2, y2. So the slope is equal to y2 minus y1 over x2 minus x1. So 4 minus 0 over 0 minus 3. So 4 over negative 3. So your answer is a negative 4/3. Let me do problem number 11. Three, 0. 3 minus 3. Call this x1, y1, x2, y2. So the slope, y2 minus y1 over x2 minus x1. The change in y over the change in x. And so the change in y, negative 3 minus 0, over the change in x, 3 minus 3. Negative 3 minus 0 is negative 3. 3 minus 3 is 0. And so the slope is undefined. And we usually are lazy and we write UND to stand for the word undefined. Let me do problem number 13. One, 4, 5, negative 3. The slope of if the slope of a line is undefined, then it is a vertical line. If you have a vertical line, then its slope is undefined. So yes. So let's call this x1, y1, x2, y2. Okay. So the slope is y2 minus y1 over x2 minus x1. And so delta y, negative 3 minus 4 over delta x, 5 minus 1. Negative 3 minus 4 is a negative 7. 5 minus 1 is 4. So your slope is a negative 7/4. 15. 3, negative 1, 1, negative 2. So let's call this x1, y1, x2, y2. So the slope is y2 minus y1 over x2 minus x1. So let's do the vertical change. Negative 2 minus the negative 1 over the horizontal change. 1 minus 3. Negative 2 minus the negative 1, same as negative 2 plus 1. So 1 minus 2 is a negative 1. 1 minus 3 is a negative 2. Negative divided by negative is positive. So your slope is a positive 1/2. Let me do problem number 17. Y equals 4x minus 1. In exercises 17 through 32, find the slope of the line. Okay, so I could do this one of two ways. So first, let me just find two points on the line. Actually, maybe And so let's say when x is 0 and when x is 1. And so x equaling 0 says that y is equal to 4 times 0 minus 1. 4 times 0 is 0. 0 minus 1 is a negative 1. And lastly, if x is 1, then y is 4 times 1 minus 1, which is 3. 4 minus 1 is 3. Okay, so let's call this x2, y2, x1, y1. So the slope is equal to y2 minus y1 over x2 minus x1. So negative 1 minus 3 over 0 minus 1. So I get a negative 4 over negative 1. Negative divided by negative is positive. And so I get a positive 4. Good. Or I could do something else. So what I should notice is the following. If the equation of my line is written in the following form, y equals some constant times x plus another constant, then this constant in front of x is the slope of the line. B is called the y-coordinate of the y-intercept. But that's what we want to figure out. So then in this case, if y equals 4x minus 1, well, the number in front of x is 4. And you're done. I like this better because it's faster. So this is the technique I'm going to use. So let me do problem 19. So you notice that if you put it in this form, the slope-intercept form, then you can easily find the slope of your line. Okay, so let me do problem number 19. 3x plus 5y equals 1. So what I have to do is I have to put it into this form. So I've got to solve for y. So let's solve for y. So subtract 3x from both sides of my equation. So I get that 5y equals negative 3x plus 1. Divide every side, every term of my equation by 5. And so I get that y is equal to negative 3/5 x plus 1/5. So that says the slope of my line is negative 3/5 because that is the number in front of x. Let me do problem 21. 2x equals y plus 1. Subtract 1 from both sides of your equation. So you get that y equals 2x minus 1. Therefore, the slope of your line is 2. Let me do problem number 23. Negative 2x plus 4y equals 7. Add 2x to both sides of your equation. Divide by 4. And so y is equal to, well, 2 divided by 4, I can divide both 2 and 4 by 2. So I get 1/2 x plus 7/4. Therefore, the slope of my line is 1/2. Let me do problem number 25. Three x minus y equals 2. Subtract 3x from both sides of my equation. So I get negative y equals negative 3x plus 2. Divide every term by negative 1. On 21. Oh, no, I didn't. Oops. It was a sleight of hand. So it's 2y equal 2x minus 1 equals y, which you could just read the other way. Y equals 2x minus 1. And so I'm not really switching sides or anything. I just read it the other way. So in this case, the number in front of x is 2. Okay. Sorry about that. I just did it, fast because it was natural to me, but I didn't even say anything. Okay, so negative y divided by negative 1 is a positive y. The negatives cancel, so you get positive 3x. Positive divided by negative is negative. Therefore, the slope of my line is 3. 27. Okay, 3x plus 3y equals 1. Subtract 3x from both sides of my equation in order to solve for y. So 3y is equal to negative 3x plus 1. Divide every term by 3 to solve for y. And so y is equal to negative divided by positive is a negative x plus 1/3. And so, since I have it in the slope-intercept form, I have that the slope is, well, there's a negative in front of the x, and so this is understood to be multiplied by negative 1. So my slope is negative 1. Problem 29. Two x minus 3y plus 4 equals 0. Subtract 2x, 4 from both sides of your equation. So you get negative 3y equals negative 2x minus 4. Divide both sides of the equation by negative 3. So I get that y, negative divided by negative is a positive 2/3 x. Negative divided by negative is a positive 4/3. And so that says that my slope is equal to a positive 2/3. Let me do problem 31. Two x plus 3y plus 5 equals 0. Subtract 2x, 5 from both sides of my equation. And so 3y is equal to negative 2x minus 5. Divide everything by 3. And so I get that y is equal to a negative 2/3 x minus 5/3. So the slope of my line is a negative 2/3. Let me do problem number 33. Consider the lines A, B, C, D, E. For each line, determine which of the following is true. Okay, so let's see if I can draw this. Where's A? That's A. No, this is A. Okay, wait 1 second. Oh, the A is blue, and that's the x-axis. Okay, so blue, A. This is line A. Line B is green. Okay, let's do green. And it's right there. B. Okay. C is like red. That's C. D is purple. Where's purple? Indigo. D is no, it's that. It's that color. Okay, it's indigo, and it looks like this. Okay, that's D, and E is, bet you it's that. So this is E. Okay, so those are all the different colored lines. Okay, so it says first, I want to figure out which slopes are greater than 0. Okay, so the slopes that are greater than 0 would be B. B is greater than 0. Next, 2. The slopes that are negative, less than 0. D, E, that's it. So D and, oops, E. Those are negative. And slope that is 0, A. I think I picked that one. That's A. And lastly, slope that's not defined. That is C. So C is undefined, has a slope that's undefined. So let's see, A, B, C, D, E. Okay, good. They're all there. Any questions about that? So notice that this has a slope that's going down. So you should read graphs going left to right. So notice that D has a slope that's negative because it is going down if I read left to right. And similarly, E has a slope that's negative because it's going down when I go read this left to right. Whereas B has a slope that's positive because it goes up as I go read it left to right. Whereas A has a slope that's 0 because it's not going, it neither goes up nor down. Whereas C is undefined because you can neither go right or left. It goes straight up and down. So it doesn't go up or down when you go right to left because it never goes right or left. So it's undefined. Any questions about that? Let me do problem 35. 3x equals 4y minus 7. Okay. So let's add 7 to both sides. So it says, in exercises 35 through 42, without drawing the line, determine whether the line is rising or falling from left to right. So all you have to do is determine the slope of this line. So you get 3x plus 7 is equal to 4y. Divide by 4. So you get that y is equal to 3/4 x plus 7/4. So that says that the slope is 3/4. But 3/4 is greater than 0. So that says that, maybe I should indicate that I went this way. And so this says that the line is rising because it's positive slope from left to right. Let me do problem number 37. Two x plus 3y equals 9. Subtract 2x from both sides. And so 3y equals negative 2x plus 9. Actually, from here you can tell that it's going to have a negative slope. But I'll continue. And so you know it's going to be falling from left to right. Divide by 3. And so, actually that's how I should probably denote it, just by a line. And so I have that y equals negative 2/3 x plus 3. So the slope is equal to negative 2/3, which is less than 0. So that says that the line is not rising but falling from left to right. Let me do problem 39. Five y minus 4x plus 1 equals 0. So add 4x, subtract 1 from both sides of your equation. So I have 5y is equal to 4x minus 1. Divide by 5. So it says that y is equal to 4/5 x minus 1/5. So that says the slope is equal to 4/5, which is greater than 0. And so that says that the line is rising from left to right. Let me do 41. x plus 7y minus 2 equals 0. Subtract x. Add 2 to both sides of your equation. So 7y is equal to a negative x plus 2. Divide by 7. So it says that y is equal to negative 1/7 x plus 2/7. And so the slope is a negative 1/7, which is less than 0. Therefore, the line is falling from left to right. Let me do problem 43. Okay, so let me draw this. Zero, 3, and 3, 0. Negative 4, 0. 0, negative 4. Okay, so it says here in exercises in exercises 43 through 50, 2 points on each line are given. Use the points to find the slope and verify that 1, the slopes of the line are parallel, and 2, the product of the slopes of perpendicular lines is negative 1. In this case, these are parallel lines, of course. So let's call this, I don't know, L1 and call this L2. So let's find the slope for the first line. Y2 minus y1 over x2 minus x1. Okay, so let's start with this point, negative 4, 0, and then subtract from it 0, negative 4. Okay, and so you get negative 4 minus 0 is negative 4. 0 minus negative 4 is plus 4. Negative divided by positive is negative 4 divided by 4 is 1. So the slope is negative 1. Let's look at the slope of the second line. So change in y over the change in x. So let's do 3 minus 0 over 0 minus 3. So I just did 3 minus 0 over 0 minus 3. 3 minus 0 is 3. 0 minus 3 is a negative 3. Positive divided by negative is negative. 3 divided by 3 is 1. Well, therefore, the slopes are the same. They're both equal to negative 1. And so these two lines are indeed parallel. since their slopes are equal. Let me do, oops, let me do problem 45. Okay, so 45. So I have here, and maybe I'll put in red. So, okay, that's the one line. Maybe call that L1. And the points are 0, 0, and 2, 2. Look at the other line. And so it is negative 4, 0, and 0, negative 4. Okay. So let me look at the slope of the first line. And so let's do y2 minus y1 over x2 minus x1. And so I have 2 minus 0 over 2 minus 0, which is 2 divided by 2, which is 1. Let me do the second line. So the slope, change in y over the change in x. And so let's do negative 4 minus 0 over 0 minus a negative 4. So this is equal to negative 4 over positive 4. Negative divided by positive is negative. 4 divided by 4 is 1. So now notice that the product of their slopes is equal to negative 1. Therefore, these two lines are indeed perpendicular. Let me do problem number 47. Let's call this L1. So it's at negative 5, 0, 3, 4. The other one is 0, 4. So let's call this L2. And 2, 0. Again, this is not really to scale, but it's close enough. Okay, so let me do slope of the first line, delta y over delta x. And so let's do 4 minus 0 over 3 minus a negative 5, which is the same as 4 minus 0, 4. 3 minus a negative 5, same as 3 plus 5, which is 8. 8 divided by 4 is 2. Okay. Let me look at the second line. So delta y over delta x. And so let's do 4 minus 0 over 0 minus 2. 4 minus 0 is 4. 0 minus 2 is a negative 2. Positive divided by negative is negative. 4 divided by 2 is 2. So let me look at the product of these. So I get 1/2 times negative 2. Positive times negative is negative. The 2's cancel, so you get negative 1. So therefore, their product is indeed negative 1. The product of their slopes is indeed negative 1. So that means that these two lines are perpendicular. Okay, 49. Yes. Actually, only because it told us to. So in the instructions, it said, use these points to find the slope and verify that the product of the slopes of perpendicular lines is negative 1. I actually usually don't. I usually just say that the other line is a negative reciprocal of the slope of the other line is the negative reciprocal of the slope of the line. So I usually don't write it as products, but sometimes I do, like these problems. So it really depends on what the question is asking you. So in this case, since they ask us, we had to do it. Okay. Okay, so let me do problem 49. So I have here, let's call this L1, 0, 5, 5, 0, and call this L2, 0, 3, 3, 0. Okay, so let's find the slope of each of these lines. So let's find the slope of the first line. So change in y over change in x. And so, first line, so I'll do 5 minus 0 over 0 minus 5. Gives me 5 over negative 5. Well, positive divided by negative is negative. The 5's cancel, so you get negative 1. Let me look at the second line. So the slope of the second line, change in y over change in x. And so let's do 3 minus 0 over 0 minus 3. So we get 3 over negative 3. Positive divided by negative is negative. 3 divided by 3 is 1. And so the slopes are equal. They're both equal to negative 1. Of course, that's a true statement. The slopes are equal. Therefore, these two lines are indeed parallel. Okay. Let me do problem 51. So let's call this L1, y equals 3x plus 7, and let's call this L2. Y equals 3x minus 5. Okay, so in exercises 51 through 78, determine whether the pair of lines is parallel, perpendicular, or neither. Okay, so let's check if these are parallel or perpendicular. Well, the slope of this first line is 3. The slope of the second line is also 3. Since the slopes are equal, then these two lines are parallel. So these are parallel lines. Let me do 53. Let's call this L1, L2. Y equals 2x plus 1, 2y equals negative 1. Well, the slope of this first line is 2. To find the slope of the second line, divide by 2. So you get y equals negative 1/2. Wait. So y equals negative 1/2, correct. So that says that the slope here is 0, because there's no number in front of x. Therefore, the slope is 0. And so, well, these two slopes are not the same, and the product of these two slopes is not negative 1. It's going to be 0. 2 times 0 is 0. Therefore, the answer is these are neither parallel nor perpendicular. Let me do 55. Three y plus 5x equals 1. 5y minus 3x plus 4 equals 0. Okay, so let's find the slope of the first line. Subtract 5x from both sides of your equation. Divide every term here on both sides of my equation by 3. So y equals negative 5/3 x plus 1/3. So that says that the slope of this first line is a negative 5/3. Let's find the slope of the second line. Maybe I'll do it here. And so I have 5y minus 3x plus 4 equals 0. Add 3x, subtract 4 from both sides of your equation. So I have that 5y equals 3x minus 4. Solve for y. Divide every term by 5. So y is equal to 3/5 x minus 4/5. So that says that the slope of the second line is 3/5. Well, they're not equal, but let's look at their product. Or actually, let me notice, let's do it the other way around. Notice that negative 5/3 is the negative reciprocal of 3/5. So notice I've switched the sign and I've interchanged numerator and denominator. So therefore, m2 is equal to the negative reciprocal of m1. So that says that these two lines are perpendicular. So these are perpendicular lines because the slope of the second line is a negative reciprocal of the slope of the first line. Or say it the other way around. The slope of the first line is the negative reciprocal of the slope of the second line. Let me do problem number 57. You could have also multiplied them together and gotten -1. Oh, sure. Okay, so let me do this again. So I have these two lines here. The first thing I want to do in order to figure out if they're parallel or perpendicular is find the slope of each line. So to find the slope of each line, I want to solve for y. So for this first equation, I'm going to solve for y. So this is L1. Okay. So to solve for y, I'll try to isolate y on one side of my equation. So I'll subtract 5x from both sides of my equation. Now I want to solve for y, so I'll divide every term by 3. And so the number in front of x is -5/3, so that's the slope of the first line. Next, I want to determine the slope of the second line. So let's do L2. So I want to isolate y on one side of my equation. So let's bring the 3x and the 4 to the other side of my equation. Now I want to solve for y. So we'll divide every term by 5. So now the number in front of x is 3/5. Notice that -5/3 is the negative reciprocal of 3/5. So I've changed the sign and I've interchanged numerator and denominator. That means that the slope of the second line is the negative reciprocal of the slope of the first line. Therefore, they're perpendicular. Or I could just have taken their product. Negative times positive is negative. 5's cancel, 3's cancel. So you get -1. So you also have that the product of the slopes is -1, meaning again that these two lines are perpendicular. Any questions about that? Okay. Let me do problem number 57. So let's call this L1. 2y equals 4x plus 7. L2. 4y plus 2x equals 0. Okay, so let's find the slope of the first line. So I've already isolated y on one side of my equation. Let me solve for y by dividing both sides of my equation by 2. So I get that y is equal to 4 divided by 2 is 2x plus 7/2. So that says the slope of the first line is 2. Let's look at the slope of the second line. Subtract 2x from both sides of my equation in order to isolate y on one side of my equation. So I get that 4y is equal to -2. Divide both sides of my equation by 4. And so y is equal to negative divided by positive is negative. 4 divided by 2 is 2, so -1/2 x. So therefore the slope of the second line is -1/2. But now notice that the product, 2 times negative a half is negative 1. Or notice that the second slope, the slope of the second line, is the negative reciprocal of the slope of the other line. So negative 1/2 is the negative reciprocal of 2. The reciprocal of 2 is a half, and so negative half is the negative reciprocal of 2. So therefore, these two lines are perpendicular. Let me do problem number 59. Two x plus 3y equals 4. 59. 6y equals 5 minus 4x. So let's first solve for L1. So let's find the slope of this first line. So first I want to isolate y on one side of my equation. So subtract 2x from both sides of my equation. So I get that 3y is equal to a negative 2x plus 4. Divide every term by 3 to solve for y. So y is equal to negative 2/3 x plus 4/3. And so that implies that the slope of the first line is a negative 2/3. Okay, good. Let's solve for the second line. And so the second line is 6y equals 5 minus 4x minus 4x. Let me divide every term here by 6. And so y is equal to 5/6 minus 4/6. Well, 4 divided by 6, I can reduce that. I can divide both 4 and 6 by 2 to get 2/3 x. So it says, in this case, the slope is a negative 2/3. And so I had that the slope for this first line, let me bring it down actually, so it's parallel to that. I had the slope of the first line was negative 2/3. Therefore, both these slopes are the same. They're both negative 2/3. So these two lines are parallel. Any questions about that? Let me do problem number 61. Mm. 7y plus 2x equals 4. 7y equals 1 plus 2x. Okay, so let me look at the first line. Subtract 2x from both sides of my equation in order to isolate y on one side of the equation. So 7y equals a negative 2x plus 4. Divide every term by 7. And so y is equal to a negative 2/7 x plus 4/7. So that says the slope of the first line is negative 2/7. Let's look at the second line. 7y is equal to 1 plus 2x. Let's solve for y. So let's divide every term by 7. So I have that y is equal to 1/7 plus 2/7 x. So the second line has a slope of positive 2/7. So now you notice the following, that the slopes are not the same. Positive 2/7 is not the same as negative 2/7. And the slopes are not negative reciprocals of each other. One is a negative of the other, but it's not a reciprocal. So negative 2/7 is not the negative reciprocal of 2/7 because you haven't interchanged the 2 and the 7. And so these are not the same. So it's neither parallel nor perpendicular. Any questions about that? So just the fact that one is a negative of the other doesn't make them perpendicular. It has to be a negative reciprocal. And neither, if one is the reciprocal of the other, that also doesn't make them perpendicular. It has to be the negative reciprocal. Let me do problem 63. Y equals 1/3 x plus 6, 2y equals 6x minus 1. Well, from this first line, I have the slope is 1/3, since it's already been solved for y. For the second line, well, let's do the second line. Let's just divide by 2. And so you get that y is equal to, well, 6 divided by 2 is 3, x minus a half. But that means that the slopes is equal to 3. But these are not the same. 3 is not the same as 1/3, and neither is 1/3 the negative reciprocal of 3. It's reciprocal, but it's not the negative reciprocal of 3. Therefore, this is neither parallel nor perpendicular lines. Let me do problem 65. Three x plus 65. 3x plus 2y equals 10. L2. Y equals 3/2 x plus 4. Okay, so let's do this. So for L1, let us subtract 3x from both sides of my equation in order to isolate y on one side of the equation. So 2y is equal to negative 3x plus 10. Divide both sides of my equation by 2. And so y is equal to negative 3/2 x plus 5. Okay. So that says that the slope of the first line is negative 3/2. But this is already in the form y equal mx plus b. So the second line has a slope of 3/2. But again, these slopes are not equal, nor is one the negative reciprocal of the other. Therefore, these lines are not parallel, nor are they perpendicular. So they're neither parallel nor perpendicular. Let me do problem number 67. Negative 5x minus 4y equals 2. Y equals 4/5 x plus 3. Okay. Let me do L1 first. So let me try to isolate y on one side of my equation. So let me add 5x to both sides of my equation. So I get negative 4y is equal to 5x plus 2. Let me divide every term here by negative 4. So I get that y is equal to a negative 5/4 x minus 1/2. And so the slope of the first line, maybe I'll put it up here, the slope of the first line is negative 5/4. And this is already in the form y mx plus b. So the slope of the second line is positive 4/5. But I notice that the slope of the first line is the negative reciprocal of the slope of the second line. And so notice one is positive, the other is negative. So they're opposite signs. One is 5/4, the other is 4/5, so they're reciprocals. Therefore, these two lines are perpendicular. Let me do 69. Okay, darn. Okay, let me do 69. Y, L1. Y equals 2x plus 1/5. L2. Negative 2x minus y equals 4. Okay, so the first line, I have that the slope is 2. Let me solve the second slope. Add 2x to both sides of my equation. And so negative y equals 2x plus 4. Divide both sides of my equation by negative 1. And so y equals a negative 2x minus 4. So that says the slope of the second line is a negative 2. But these two lines, these two slopes are not the same. 2 is not equal to negative 2, and neither is negative 2 the negative reciprocal of 2. So these two lines are neither parallel nor are they perpendicular. Let me do 71. 2x plus 3y equals 9. L2, 3x minus 2y equals 12. Okay, so let me solve L1 first. Subtract 2x from both sides of my equation. So I have that 3y equals negative 2x plus 9. Divide both sides of my equation by 3. So y equals negative 2/3 x plus 3. So the slope of the first line is negative 2/3. Let's find the slope of the second line. 3x minus 2y equals 12. Subtract 3x from both sides of my equation. So negative 2y equals negative 3x plus 12. Divide both sides of the equation by negative 2. So y equals negative divided by a negative is a positive. 3/2 x minus 6. So the slope of the second line is a positive 3/2. So the slope of the second line is the negative reciprocal of the slope of the first line. Negative 2/3 is the negative reciprocal of positive 3/2. Notice one is negative, the other is positive. 2/3 and 3/2 are the same, except we've interchanged numerator and denominator. Therefore, these two lines are perpendicular. Okay, good. 73. L1 x minus 2y plus 3 equals 0. L2 2x plus y equals 9. Oops, plus 9 equals 0. Okay, so let's find the slope for the first line. Try to isolate y on one side of my equation. Subtract x, 3 from both sides of my equation. So negative 2y equals negative x minus 3. Divide every term by negative 2. And so y is equal to a positive 1/2 x plus 3/2. So the slope of the first line is a positive 1/2. Let's look at the second line. Subtract 2x, 9 from both sides of my equation in order to isolate y on one side of my equation. So the slope of the second line is negative 2. The slopes of the first line is the negative reciprocal of the slope of the second line. Therefore, so notice that if you multiply these together, you get a negative 1. Therefore, these two lines are perpendicular. Let me do problem number 75. Y equals negative x plus y. Y equals x minus 7. Okay, so let's look at the first line. Subtract y from both sides of my equation. So this says that x is equal to 0. So there's no y here. Therefore, the slope is undefined. Okay, let's look at the second line. Well, for the second line here, I already have that y is already equal to mx plus b. So the second slope is 1. Okay, and so these slopes are not the same, nor are they negative reciprocals of each other, nor is their product -1. So they're neither parallel nor perpendicular. 77. 2x minus 9y equals 1. 9x plus 2y equals 18. So let me determine the slope of the first line. Oh, this is the last problem, I believe. It'll probably be in about 1 minute. Let me subtract 2x from both sides of my equation. So minus 9y equals minus 2x plus 1. Let me divide both sides of my equation by -9. And so I have here, that y is equal to positive 2/9 x minus 1/9. So the slope of the first line is 2/9. Let me determine the slope of the second line. And so I have here 9x plus 2y equals 18. Subtract 9x from both sides of my equation. So I have 2y equals negative 9x plus 18. Divide both sides of my equation by 2. And so y is equal to negative 9 halves x plus 9. Therefore, the slope of the second line is negative 9 halves. But you notice that these are negatives of each other's, and they're reciprocals. 2/9 and 9 halves are reciprocals of each other. So these two lines are perpendicular. So that finishes off problem number 77. Let me look. I think that's it. Let's see, section 3.4. That's it. Okay. So that's it for today. And I'll see you guys on Monday at the same time. Okay. See you. There it is.